The night sky is not empty. It is a stage of endless arrivals, a black ocean upon which visitors glide without warning, carried not by the tides of Earth, but by the vast currents of the cosmos. Among the stars, one such visitor appeared, a small, cold ember against the silence, born not in the familiar neighborhood of planets and comets, but from the unimaginable elsewhere. It was christened 3I Atlas, the third interstellar object ever to reveal itself to human eyes. Yet from its first moments, it carried with it not only data and light curves, but a whisper: what if this was never natural at all? Astronomers have long waited for such apparitions. The sky holds traces of countless wanderers, shards torn from foreign solar systems, flung out into the dark by the chaotic gravity of young stars. Most never cross our path. Most are forever invisible, swallowed by distance and void. But sometimes a fragment slips close enough to be seen, close enough to ignite a moment of awe. Oumuamua in 2017 was the first, then 2I Borisov in 2019. And then, as if on cue, 3I Atlas followed an arrival that felt less like random chance and more like a message in sequence, a punctuation mark in a cosmic language we did not yet understand. From the beginning, 3I Atlas seemed touched by strangeness. Its entry into our skies was almost imperceptible, a ghostly glimmer noticed only because our instruments had become vigilant since the shock of Oumuamua. But even in that faint light, something was unsettling. Its path traced a geometry too pure, a speed too steady, a resilience too clean. It carried the poise not of a drifting rock, but of a crafted thing, a vessel shaped against the storm. To call it engineered is to trespass into dangerous territory. Science demands restraint, skepticism, the discipline to hold wonder at bay until evidence forces the mind to yield. And yet the thought cannot be fully silenced. For what is engineering but the act of intention upon matter? And what is 3I Atlas, if not a body that seems to have resisted chaos longer and more perfectly than any mere ice or stone should? In this first encounter with Atlas, one feels the echo of old myths. Ancient peoples once watched comets with dread, believing them harbingers of war, famine, or divine judgment. But this is no mere superstition. The shock of Atlas lies in the same uneasy place, that the heavens, thought to be impersonal and mute, may not be indifferent at all. Something or someone might have written this object into the sky, letting it fall into our vision not as accident, but as signal. So the journey begins here, with a question suspended like a candle flame against eternity. What if 3I Atlas was not natural, but engineered? It was in the year 2019 that the discovery unfolded, almost quietly at first, hidden within the endless stream of data gathered by watchful eyes of humanity's skyward instruments. The Atlas Survey Asteroid Terrestrial Impact Last Alert System was scanning for danger, a sentinel designed not for wonder but for warning. Its task was simple and solemn: to notice objects that might endanger the Earth. What it found instead was something stranger, a fragment from the outer dark, drifting through our system with a trajectory that told a story more ancient than Earth itself. Astronomers combed through data in silence, their work marked by patience, calculation, and an almost monastic discipline. On that night, the system flagged a faint point of light, nearly lost in the background noise of stars. At first, it was nothing remarkable. Many detections vanish into the ledger of ordinary near-Earth objects. Yet when the orbit was calculated, when the numbers revealed their geometry, there was a moment of stunned stillness. This was no child of the Sunday. Its path did not loop back like a comet bound by our star's gravity. Instead, it cut through the solar system like a blade, tracing a hyperbolic arc. Its speed was too great, its origin too distant. It was not of here. News spread slowly, then quickly. Observatories across the world redirected their gaze, feeding on the urgency of the find. For the third time in recorded history, humanity had captured an interstellar object in the act of passing by. It was designated 3I Atlas, the third interstellar 3I visitor, named for the survey that revealed it. And just like its predecessors, Oumuamua and Borisov, it stirred the scientific imagination with questions too vast to contain. But even in those first days, there was something unsettling about Atlas. Unlike Borisov, which appeared convincingly comet-like, or Oumuamua, which defied categories with its shape and acceleration, Atlas carried traits that seemed curiously deliberate. It shone with an intensity that shifted in ways hard to explain, as though it pulsed with its own rhythm. Its orbit was not just hyperbolic, but eerily precise, intersecting our observational reach with almost theatrical timing, as though it wanted to be seen. This possibility was never spoken outright in the first reports. Official language remained cautious, clipped, careful not to indulge in speculation. And yet, beneath the equations, one could sense the hum of unease. Could it be that this was not merely a stone cast into space, but something else, something built, dispatched, and guided? For a moment, science returned to its oldest form, not the cataloguing of facts, but the confrontation with the unknown. The night sky had opened, and through that opening, 3I Atlas arrived, a fragment of the cosmos, or perhaps a message waiting to be read. To understand the strangeness of 3I Atlas, one must place it alongside its two predecessors, those earlier visitors that cracked open the imagination of both scientists and the public. In 2017 came Oumuamua, the first known interstellar object, its name drawn from Hawaiian, meaning a messenger from afar arriving first. It was elongated, tumbling, and disturbingly resistant to easy classification, too shiny, too fast, and accelerating in ways that ordinary comets could not. Then, in 2019, 2I Borisov appeared, discovered by an amateur astronomer in Crimea. Unlike Oumuamua, Borisov looked more like what one might expect: a comet with a coma, a tail, and familiar behavior. It reassured scientists proof that some interstellar wanderers might resemble the icy debris we already knew. And then came the third, 3I Atlas. To casual eyes, 3 in quick succession might seem unremarkable. Surely the heavens must be filled with such nomads. But the timing felt uncanny. For centuries, no interstellar objects had been observed, and only with the dawn of powerful sky surveys did the first arrive. Yet to receive 3 so quickly, almost as if in sequence, gave pause. The cosmos seemed suddenly less empty, less silent. Oumuamua was the enigma, Borisov the comfort, Atlas the provocation. If Oumuamua was a whisper and Borisov a sigh, Atlas felt like a question mark hurled across the night. Why 3? Why now? Was this a statistical inevitability, a sign that the universe was finally revealing what had always been hidden? Or was there another layer, an orchestration, a cadence, as though someone were placing pieces onto a cosmic chessboard for us to find? The scientific community resisted such thoughts. Natural explanations were their duty, the scaffolding of rational inquiry. Yet even the act of comparing the 3 objects seeded unease. Oumuamua's acceleration without a visible tail, Borisov's almost too typical cometary form, and Atlas's strange coherence seemed to form a trinity of contrasts: anomaly, conformity, and suggestion. Each new arrival changed the context of the last, retroactively reframing their meaning. If Atlas were alone, it might have been dismissed, but as the third, it belonged to a lineage, and lineages imply pattern. Humans are pattern-seeking beings. It is our oldest instinct. We look into constellations and see heroes, animals, myths, We watch 3 interstellar bodies arrive within 3 years and wonder, is there design in this sequence? Is chance enough to explain the rhythm? For science, these were dangerous questions, yet for philosophy, they were irresistible. Perhaps the story of Atlas was not just about a single object, but about its place in a chain, an unfolding narrative written across the stars, each chapter timed to the awakening of our instruments, each one daring us to ask, what if we are meant to notice? Once 3I Atlas had been announced, telescopes across the Earth and in orbit turned their gaze upon it. To capture such a fleeting visitor is no small task. Interstellar objects rush through the solar system with merciless speed, offering only weeks or months before they vanish into the void again. Every hour mattered, every photon was precious. Observatories scrambled, aligning glass and mirrors, eager to catch whatever fragments of truth the object would reveal. The first reports focused on brightness. Atlas shimmered in ways that did not follow the usual curve of a comet, fading with distance or brightening as sunlight freed its volatiles. Instead, its light was irregular, as if modulated by unseen hands. The glimmer seemed to change, not chaotically, but with hints of rhythm patterns that defied easy categorization. Its trajectory confirmed the interstellar nature, a hyperbolic path, inbound at a velocity that no solar system object could sustain. It would not return, it was not bound to the Sunday. It was passing through like a wanderer, pausing only to leave us questions. Scientists marked its speed with wonder. Tens of kilometers per second, fast enough to laugh at planetary gravity, fast enough to be gone before we could fully know it. Spectroscopic measurements came next, decoding the fingerprint of its light. Yet here, too, strangeness emerged. Some of its features mimicked common comets, water, dust, simple organic molecules, but others refused to conform. Gaps where signals should have been, anomalies in ratios, shadows in the data that stirred unease. Was this an incomplete reading? A trick of distance? Or something less natural, concealed within a skin of comet-like disguise? Most curiously, observers noted the coherence of its structure. Where many comets fracture under solar heat, Atlas remained stubbornly intact, its nucleus holding form against stresses that should have splintered it. Astronomers speculated about hidden strength, unusual density, or protective composition, but in private conversations, some allowed themselves to wonder, was this resilience engineered? Could this be a hull, not a stone? Even its silence carried weight. Instruments strained for radio signals, for whispers across the electromagnetic spectrum. Nothing came. If it was a messenger, it spoke in riddles of light and motion, refusing to answer in our tongue. These first observations set the stage for the greater mystery. Atlas was not overtly impossible, not flamboyantly alien. It hovered on the threshold, enough to appear comet-like, yet laced with inconsistencies, sharp enough to wound our certainties. It was the tension of the almost believable, a puzzle that dared us to choose between chance and intention. In those weeks of frantic measurement, the scientists of Earth were not merely observing an object. They were confronting the possibility that the night sky had been seeded with questions too deliberate to ignore. When the data on 3I Atlas was gathered into careful tables and equations, a subtle unease began to ripple through the scientific community. At first, numbers seemed to offer comfort. Numbers always do. They framed the object in units and constants, pinned it down in orbital mechanics, reduced its wild passage to predictable coordinates, but within those parameters, strangeness emerged. The orbit of Atlas was unmistakably hyperbolic. That much was expected. Any interstellar body passing through the solar system would follow such a path, swooping in under the sun's gravity before racing back out to the galactic void. Yet the precision of its course raised questions. Unlike Borisov, whose cometary disintegration clouded its trajectory with dust and drag, Atlas moved with eerie clarity. its arc almost too clean. The equations aligned with unusual perfection, as though crafted rather than inherited from the chaotic violence of planetary systems. Its velocity, too, was peculiar. Entering at around 30 kilometers per second, it was neither unusually fast nor sluggish for an interstellar traveler. But simulations suggested that its speed was tuned with uncanny exactness to carry it into a visible path across Earth's skies, within reach of the very instruments designed to notice such anomalies. Chance could explain this, chance often does, yet chance had begun to strain under the weight of repetition. Then came the question of its size. Estimates placed its nucleus in the range of several hundred meters, perhaps larger. Too large to be dismissed as trivial debris, yet too small to fit comfortably within the class of stable interstellar asteroids. Its dimensions sat awkwardly between categories, as though selected for balance, big enough to endure the journey, small enough to evade easy detection until it was almost upon us. The light curve, always the astronomer's secret language, spoke another riddle. Variations in brightness suggested rotation, but the rhythm was inconsistent, as though the object spun and yet resisted full disclosure of its shape. Natural bodies often wobble irregularly, but here the irregularity seemed patterned, shifting in ways that hinted at layers beneath. Could this be an outer shell concealing an inner form? Could its motion be dampened, controlled, or stabilized by something beyond the familiar physics of tumbling rock? Taken individually, each of these parameters might be explained away: coincidence, error, imperfect data. But taken together, they formed a portrait not of impossibility, but of discomfort. Atlas conformed too much in some ways, too little in others. It was the anomaly of near normalcy, the sense that what you were seeing was arranged to look almost but not entirely ordinary. The unsettling truth was not that Atlas broke the laws of physics, it obeyed them. The unsettling truth was that it obeyed them with a precision too sharp, too purposeful, leaving behind the faint impression not of chaos, but of design. Light is often the first and last messenger from distant objects. It carries the fingerprints of chemistry, the rhythms of rotation, the scars of collisions, and the subtle whispers of age. For 3I Atlas, light became the central enigma, a glow that refused to follow the familiar rules of comets and asteroids. Ordinary comets announce themselves with drama. As sunlight heats their frozen surfaces, volatiles escape in great plumes, forming bright comas and sweeping tails. The physics is elegant and predictable. More heat means more sublimation, more gas, more dust, more light. Brightness rises and falls in rhythm with distance from the Sunday, yet Atlas resisted this narrative. Its glow pulsed faintly, fluctuating not with distance or angle but in ways that suggested hidden triggers. Sometimes its brightness spiked with no clear cause, as though it were lit from within. Astronomers plotted these variations, searching for periodicity, a rhythm that might indicate rotation or surface geometry, but the data refused easy interpretation. The changes were not random noise, but neither were they neatly periodic. It was as though the object spoke in half patterns, the way waves break unevenly on a shore, or the way coded messages hide in seeming irregularity. Some observers suggested the anomalies could be explained by unusual composition, ices of exotic chemistry, releasing gases under subtle thermal thresholds. Others pointed to the possibility of dust jets erupting from hidden fractures, spraying material in unpredictable bursts. But beneath the scientific caution, another thought lingered. What if this was not eruption at all, but emission? What if the light itself was modulated, tuned, or even controlled? Oumuamua had raised similar whispers when its brightness swung wildly, hinting at a flat, elongated shape tumbling in space. Atlas seemed to echo the same unease, though in a quieter register. Where Oumuamua was dramatic, Atlas was restrained, its glow almost theatrical in its subtlety. It felt like a performance meant to be noticed but not understood. The glow was not just puzzling, it was haunting. To watch it shimmer in the dark was to be reminded of fireflies signaling in the summer night, of lighthouses pulsing across stormy seas. These human metaphors clung to it, though they had no place in data tables. Still, the suggestion was unavoidable. Atlas looked less like debris reflecting sunlight and more like a lantern carried across the void. And if it was a lantern, the question grew darker still. Who or what lit it, and why? In science, true shocks are rare. The universe, vast and indifferent, usually abides by its own patient rules, offering riddles that can be solved with time, persistence, and mathematics. But every so often, something arrives that refuses to fit. For Oumuamua, it was the acceleration without a cometary tail. For 3I Atlas, the shockwave came from the realization that its coherence, its stubborn integrity, defied natural expectation. Comets are fragile. They are the remnants of planetary construction, loose conglomerates of ice and dust, bodies so brittle that the faint touch of sunlight can tear them apart. We have watched countless comets split, fragment, and dissolve under solar radiation. They are beautiful, but ephemeral snowballs burning as they fall toward the fire. Yet 3I Atlas did not obey this fate. Even as it neared the sun, even as its surface should have cracked and boiled, the object held together with unnerving persistence. The spectrographs whispered of ice. Yes, but ice wrapped in something else, something that gave it strength. It rotated, but did not wobble into chaos. It brightened, but not explosively. Instead, it displayed the poise of an object that had been made to endure, like a pearl resisting fracture, like a crafted vessel weathering the sea. This was the first moment when some dared to speak in half-confidences, quiet conversations in conference corridors and late-night emails. Could this be engineered? Could this resilience be evidence of intention? To suggest such a thing openly was perilous. Careers have been undone by less. Yet the thought pressed in, perhaps this was not a comet at all, but something designed to appear as one. The shock was not that Atlas existed. The shock was that it existed too well. A natural body should have betrayed weakness, should have crumbled in the face of solar heat and gravitational stress. Atlas did not. It held together like a thing that knew it must survive the journey, a thing built with purpose. For some, the explanation remained natural, an unusually strong body, perhaps with hidden metals or frozen compounds unknown in our system. But for others, a shadow lengthened a suspicion that 3I Atlas might not simply be matter, but message. A message written not in words, but in the refusal to shatter. That refusal was the shock wave. It reverberated through observatories and journals, unsettling not because it broke the laws of physics, but because it bent them with the elegance of design. No object haunts the scientific imagination more than Oumuamua, the first true interstellar visitor confirmed by human eyes. When it crossed our solar system in 2017, it forced astronomers into an uneasy space between data and speculation. Unlike any comet or asteroid seen before, it bore a peculiar shape, flat, elongated, perhaps cigar-like, though its exact geometry remained hidden in flickering light curves. Most troubling was its motion. As it drifted away from the sun, it accelerated, nudged by some unseen force. No tail, no jets, no outgassing could be detected to explain it. Nature had given us a riddle that behaved more like a ship than a stone. Into that memory came 3I Atlas. The moment it was declared interstellar, comparisons were inevitable. Oumuamua had conditioned us to look for signs of the unnatural, had seeded the suggestion that not all cosmic visitors must be children of chance. Atlas arrived into this legacy, framed from the beginning not only as an astronomical curiosity, but as a possible successor in mystery. The parallels were striking. Both objects displayed brightness variations that refused simple modeling. Both resisted easy categorization, neither wholly cometary nor convincingly asteroidal. Both appeared in the era of vigilant sky surveys, almost as if timed to our awakening gaze. And both stirred whispers of something more, the possibility of engineering, the thought that the universe might carry artifacts, not just debris. Yet the differences mattered just as deeply. Where Oumuamua was dramatic, its shape extreme, its acceleration undeniable, Atlas was quieter, more ambiguous. Its anomalies were subtle, its behavior less theatrical, but perhaps more unnerving for that very reason. It seemed crafted to linger in doubt, to sit on the edge between natural explanation and artificial suggestion. If Oumuamua startled like a sudden shout, Atlas unnerved like a whisper in the dark. Some wondered aloud whether the two were connected. Could Atlas and Oumuamua be fragments of the same origin, dispatched from a distant system or from an intelligence with purpose? Were they scouts, probes, or drifting wreckage of technologies we cannot imagine? The probability of two anomalies within a few years was small enough to feed such speculation, and when Atlas joined their company, the sense of pattern grew heavier. Others clung to restraint. Perhaps Oumuamua was merely an elongated shard of rock, and Atlas merely a cometary oddity. Together, they represented nothing more than coincidence amplified by human hunger for meaning. Yet even those voices betrayed unease, for in the silence of space, coincidence often feels like design. Comparisons to Oumuamua revealed more than data, they revealed the limits of our imagination. To see Atlas through that lens was to inherit not only science, but suspicion, the creeping thought that perhaps we are not simply observers of nature, but witnesses to intention. As the weeks passed and astronomers refined their measurements, the riddle of 3I Atlas shifted toward its rotation and stability. Natural bodies, especially those born of collision and violence, usually spin with imperfections. They tumble chaotically, their moments of inertia unbalanced, their light curves betraying a clumsy dance. Many comets reveal this instability as they approach the sun. Jets of gas force them into erratic spins, fragmenting their surfaces and hastening their demise. But Atlas seemed to resist such disorder. Its rotation, inferred from subtle fluctuations in brightness, suggested not chaos but equilibrium. It spun, yes, but not in the way one expects from a random shard of rock and ice. The data hinted at control, a steadiness almost unnerving in its composure. Unlike Borisov, whose disintegration testified to its fragility, Atlas held its posture. Unlike Oumuamua, whose tumbling rotation defied prediction, Atlas maintained a rhythm closer to calm intention. This stability led to unsettling implications. For a natural body to maintain such balance across an interstellar journey lasting millions of years, it would need improbable fortune, a geometry nearly perfect, a structure unusually coherent, a history unmarked by catastrophic impacts. Chance could grant this, but chance seemed to be growing thin as an explanation. If instead it was crafted, then stability would not be surprising at all. A vessel meant to endure must be designed to do so. Astronomers debated density, composition, internal structure. Perhaps Atlas was composed of alloys denser than typical cometary ice, or locked together by forces we only dimly understand. Perhaps cryogenic processes hardened it into a monolith, a frozen core shielded against thermal fracture. And yet, each theory felt provisional, an attempt to dress the unknown in familiar garments. The most provocative question was simple. If Atlas spun so cleanly, who or what set it spinning? Rotation in space is not random. It is the residue of forces, collisions, outgassing, or deliberate torque. Natural causes could explain it, but so could the hand of engineering, a calculated spin to maintain orientation, to regulate heat, or to preserve equilibrium during an infinite voyage. It was here that Atlas began to feel less like an object and more like an artifact. Stability is the signature of survival, and survival, in the harsh silence between stars, is rarely an accident. To study Atlas was to confront that possibility, that its steadiness was not a fluke of geology, but a whisper of intention, a quiet declaration that this body was built to last. In the corridors of observatories, behind the guarded language of academic journals, a fragile thought began to take shape. It was not written boldly, not yet science is cautious, and reputations are brittle. But in hushed conversations and late-night exchanges, the idea surfaced. What if 3I Atlas was not natural at all? What if it was engineered? This was not an easy suggestion to entertain. The scientific method thrives on parsimony. Never multiply causes beyond necessity. Never invoke design when chance will suffice. For centuries, this discipline has protected astronomy from myth, from the easy seduction of seeing gods and portents in every wandering light. Yet, with Atlas, the old line blurred. Its coherence, its brightness, fluctuations, its improbable stability, each detail could be explained away individually, but together they gathered weight. A pattern of improbabilities began to feel like intent. Oumuamua had already opened this door. Avi Loeb, a respected astrophysicist at Harvard, had proposed in print that the 2017 object might be a probe or fragment of alien technology. His argument had drawn criticism, even ridicule, yet it had also set a precedent. It was no longer forbidden to whisper the possibility of engineering. Atlas, arriving only 2 years later, seemed to build on that precedent, like the second act of a drama too deliberate to dismiss. The hypothesis was simple, yet terrifying in its implications. If Atlas was engineered, then somewhere out there, beyond the interstellar dark, was an intelligence capable of crafting vessels that endure for millions of years, crossing gulfs we can barely measure. Such an intelligence would be ancient, powerful, deliberate. It would also be watching, or at least leaving artifacts for others to watch. The immediate counter-arguments were strong. Extraordinary claims require extraordinary evidence. No instruments had detected signals. No structure more than cometary reflection had been proven. Without a shard in hand, without direct proof, all such musings risked being dismissed as science fiction. But the seed had been planted, and it grew in silence. For those willing to step beyond the bounds of caution, the vision was staggering. Atlas as a probe, perhaps passive, perhaps active. Atlas as a fragment of an interstellar arc, broken yet purposeful. Atlas as camouflage, wearing the mask of a comet while hiding mechanisms within. Each speculation pulled the imagination further, into a territory where astronomy and philosophy entwined. And so the hypothesis emerged, fragile but radiant. Perhaps this visitor was not merely a stone hurled by the indifferent cosmos. Perhaps it was a message written by hands unknown, a deliberate presence disguised as chance. To accept, even as a thought experiment, that 3I Atlas might be engineered is to open a door into a realm of staggering possibility. What kind of intelligence, what kind of civilization could craft an object meant to endure across interstellar distances? Who are these engineers we imagine, and what goals might they pursue in dispatching such a vessel into the abyss? The scale alone is humbling. For Atlas to travel between stars, it must endure journeys that span millions, even billions of years. Its hull, if hull it is, would need to resist cosmic rays, dust impacts, gravitational perturbations, and the sheer emptiness of interstellar space. Human technology is fragile by comparison. Our probes, Voyager, Pioneer, New Horizons, are brave emissaries, but they are not eternal. They carry whispers of our presence, but within centuries or millennia, they will fall silent, their circuits darkened by radiation, their structures eroded by time. To imagine Atlas as engineered is to imagine builders whose mastery of materials surpasses ours beyond measure. They may work with alloys unknown, or weave matter at the atomic scale into fabrics resistant to entropy itself. Perhaps they exploit quantum effects, harnessing physics we only dimly understand to create endurance far beyond our engineering. But intention matters as much as capability. Why send such an object? Was it meant as a probe, silently recording and transmitting data back across distances too vast for us to conceive? Was it a relic, a fragment of some ancient migration, drifting long after its creators were gone? Or was it a marker, an artifact placed to be found, a cosmic breadcrumb in a trail scattered across the galaxy? Some theorists entertain the idea of von Neumann probes, machines that replicate themselves as they move from star to star, seeding exploration with exponential reach. Could Atlas be a fragment of such a lineage, an autonomous machine wearing the skin of a comet to avoid notice? Others suggest it could be a failsafe, a warning device, or even a test, a crafted anomaly designed to see if emerging civilizations like ours are capable of noticing. The philosophers remind us, in imagining alien engineers, we reveal our own dreams and fears. We project onto the void our anxieties of survival, our longing for contact, our dread of insignificance. Perhaps the engineers we imagine are not alien at all, but reflections of ourselves, what we might become if time and knowledge were granted without end. And so Atlas becomes a mirror. In asking who built it, we ask who we might one day be, builders of vessels to cross the abyss, or watchers of a sky seeded with questions we are too young to answer. To imagine 3I Atlas as engineered is to confront the brutal geography of interstellar space. Distances stretch beyond human intuition. The nearest star, Proxima Centauri, lies more than 4 light-years away, a gulf that light itself requires years to cross. For matter, bound by inertia and limited by energy, such a journey is not simply a passage, but an ordeal. To survive it, an artifact must obey the deepest rules of physics, rules that Albert Einstein unveiled in the early 20th century. Relativity dictates the terms of travel. Nothing with mass can exceed the speed of light. The faster a body moves, the more energy it demands to accelerate further, approaching infinity at the threshold of light speed. This limit defines the horizon of possibility for any vessel, natural or engineered. If Atlas was crafted, then its makers understood this limit and built within it, not against it. Its trajectory, neither reckless nor impossible, suggests design calibrated with precision, fast enough to cross vast distances, slow enough to remain within the strictures of relativity. But relativity also grants strange gifts. Time dilates at high velocities. A craft moving close to light speed experiences time differently from those who remain still. To the builders of Atlas, perhaps the journey did not seem endless. Perhaps what to us appears as millions of years of wandering was, to them, only a heartbeat. Einstein's equations, once abstract symbols on paper, become the architecture of survival itself. Gravity, too, is part of this story. Space is not a void but a fabric, curved and warped by mass. To traverse the galaxy may require more than engines, it may require skillful use of the cosmos itself. Slingshots around stars, maneuvers through gravitational wells, surfing the curves of space-time like a sailor reading winds. Could Atlas's hyperbolic path have been not an accident, but an intentional glide through the sun's field, a subtle nod to those who would one day recognize its mastery of celestial mechanics? The road between stars is perilous, littered with hazards. Dust grains strike like bullets at high speeds. Radiation gnaws at matter, turning metals brittle and electronics mute. If Atlas was engineered, then its builders found ways to shield it or to construct it from materials indifferent to such assaults. Perhaps its coherence, so troubling to astronomers, is simply the fingerprint of such technology, a structure woven not for beauty, but for endurance against the rules Einstein described. Relativity does not forbid interstellar travel. It sets the boundaries within which ingenuity must work. And within those boundaries, Atlas whispers of possibility, a vessel obeying the laws of physics, yet shaped so elegantly within them that it hints at intention. In contemplating Atlas against the backdrop of Einstein's universe, one sees not violation but mastery, an object moving as if it knew the rules better than we do, an artifact tuned to the very fabric of space-time. Every natural object carries the scars of chaos. Asteroids are misshapen remnants of collisions, their surfaces pocked with craters, their spins uneven. Comets wander erratically, their outgassing unpredictable, their trajectories shifted by invisible jets of dust and gas. Even planets betray imperfection, axial tilts, eccentric orbits, magnetic fields that flicker and wander. Nature's handwriting is rough, jagged, improvisational. But 3I Atlas, in its journey through the solar system, seemed to trace a line that bore the mark of something else: precision. Its trajectory through the inner solar system was plotted with exquisite clarity. Computer models projected its path backward and forward through time, and the numbers revealed not the messy drift of debris but a clean, deliberate arc. It entered with just enough velocity to escape, just enough angle to carry it past the Sun without collision, just enough alignment to sweep close to Earth's observational reach. It was, as one astronomer remarked quietly, a perfect flyby. This perfection is what disturbed some observers most. Random objects rarely present themselves so conveniently. They do not pass close enough to be studied in detail, timed precisely when our instruments are capable of seeing them. They do not navigate with the grace of a probe tracing a planned course, yet Atlas did. Its path seemed tuned not for survival alone, but for visibility. It was as though someone had placed it where we could not help but notice. More curious still was the lack of perturbation. As comets approach the Sun, their orbits often shift subtly, nudged by uneven outgassing. Atlas showed little of this. Its path held with uncanny fidelity to predictions, as though no hidden forces pushed upon it. To skeptics, this was simply data uncertainty. To others, it was evidence of control. Could this control be natural? Perhaps Atlas was composed of materials resistant to sublimation, armored against the Sun's heat. Perhaps its geometry minimized drag, granting it unusual stability. But to imagine it as engineered is to see these same traits as signatures: deliberate shaping, intentional shielding, guidance calculated with an alien exactness. The light curves added to the unease. Variations suggested rotation, yes, but in ways too smooth, too modulated, as if dampened by design. Natural tumbling is messy. Atlas's rhythm felt tuned, closer to a gyroscope than to a shard of cosmic rubble. Scientists avoid words like design. They prefer probability, statistics, models. Yet even the most restrained were forced to admit Atlas behaved with a precision that made it difficult to treat as mere chance. It was the kind of precision that whispers of hands unseen, an invisible geometry inscribed into the void. And so, the question sharpened. Was this precision simply the improbable elegance of nature, or was it the faint, deliberate signature of an intelligence that wanted to be noticed but not understood? As telescopes continued to watch 3I Atlas, astronomers reported an event that, at first glance, seemed reassuringly ordinary. The object began to fragment. Many comets do this when nearing the Sunday. Their fragile nuclei, heated unevenly, crack and burst apart, scattering shards that trail behind them like crumbs dissolving into the void. It was, on the surface, nothing unusual. But with Atlas, even disintegration refused to obey the familiar script. The breakup came with uncanny timing. It was neither too soon nor too late, but at a moment that ensured Earth's observatories could record the event in detail. Some noted that the fragments appeared to separate in oddly clean divisions, as though the object were peeling itself apart along hidden seams rather than shattering chaotically. Natural forces can explain much thermal stress, tidal forces, internal pressure, but the regularity of these fractures unsettled those who studied them closely. Even more curious was the coherence of the pieces. Instead of dispersing wildly, the fragments seemed to hold formation, drifting apart with a discipline that looked almost choreographed. Their brightness rose and fell in ways that defied simple models of dust clouds. It was as though the breakup itself had been staged, an act of theatre performed before our instruments. For some, this was the final straw. If Atlas had been anomalous before, its fragmentation now felt almost scripted. Could this be camouflage, a way of mimicking the behavior of comets, disguising its true structure beneath a performance of destruction? Could the pieces themselves have been modules, designed to separate deliberately, each carrying a part of the whole into different trajectories? The suggestion was dangerous, yet irresistible. Skeptics pushed back. Data was incomplete. Noise corrupted signals. Confirmation bias haunted every interpretation. To leap from irregular fragmentation to engineering was, they argued, to cross a canyon without a bridge. And yet, in the private language of unease, the thought lingered. Perhaps what we saw was not failure, but intent. The human mind is trained to recognize patterns in collapse. When a building falls, we distinguish accident from demolition. When a vessel breaks apart, we know whether it's splintered or separated along designed lines. In Atlas, that intuition stirred. Its fragments did not fit our models of random destruction. They fit something else, something that hinted at choreography, as though the object had been built to perform this very act when the time came. If so, the question deepens. Was the fragmentation of Atlas the end of its story, or the beginning? When the first observers charted 3I Atlas, they noted how its brightness rose and fell in ways that defied simple explanation. At first, these variations were dismissed as irregular reflection sunlight bouncing from an uneven surface, or jets of sublimating ice flashing unpredictably. But the patterns refused to vanish. They lingered, repeating just enough to tease the imagination. Astronomers are trained to search for rhythm. In the flicker of a pulsar, the dimming of a transiting planet, the echo of gravitational waves, it is rhythm that transforms noise into signal. And so, some began to ask, was Atlas speaking in light? The suggestion bordered on heresy. To imply intent in brightness variations is to invoke communication, and communication implies a sender. Yet, as data was logged, the question returned, like an echo that could not be silenced. The fluctuations were not random. They seemed clustered, pulsing with uneven intervals, almost like syllables carved into the night. If one entertained the idea of engineering, these pulses could be seen as more than accident. A rotating structure could be designed to reflect light at specific intervals, encoding information in a binary language of brightness and shadow. The glimmers could have been a beacon, faint but deliberate, a lighthouse sweeping across the galactic sea. SETI researchers toyed with the possibility. Some even ran algorithms, searching for repetition, prime numbers, sequences too meaningful to be natural. No conclusive results emerged, but the allure persisted. The silence of radio waves, so often interpreted as the absence of intelligence, did not rule out the possibility of other channels. Perhaps the builders of Atlas did not speak in radio. Perhaps they spoke in light, in rhythms woven into the very reflection of their vessel. To skeptics, it was all too easy to dismiss. Data gaps, observational bias, and the chaotic nature of cometary activity can conspire to mimic patterns where none exist. Humans are pattern-seeking creatures, willing to see language in clouds and gods in stars. But still, the suspicion clung. For those who gazed long at Atlas, the thought would not die. Perhaps this was not noise, but message. Perhaps the flicker of its brightness was the alphabet of another mind, etched into motion and reflection, awaiting someone capable of deciphering it. And if so, then 3i Atlas was not merely a visitor. It was a voice, one speaking across the void in the oldest language of all, the dance of light in darkness. If 3i Atlas was a messenger, astronomers naturally turned to the instruments best suited to catch its voice, radio telescopes. For decades, SETI, the search for extraterrestrial intelligence, has combed the skies for signals in the electromagnetic spectrum, seeking the unmistakable signature of intention among the static of the cosmos. When Atlas was confirmed as interstellar, it became an immediate target. The great dishes listened, arrays pointed their ears skyward, tuned to frequencies where nature is quiet and communication is efficient. Days and nights of observation passed. Algorithms sifted terabytes of noise, and still the result was silence. No narrowband signals, no structured pulses, no whispers of coded transmissions. The skies remained mute. To many, this silence was the final verdict. Atlas was not transmitting and therefore not engineered. To others, it was only the beginning of a deeper question, for silence itself can be a choice. A probe might travel in secrecy, its builders cautious, unwilling to reveal their presence until conditions are met. It might transmit in bands we do not monitor, or at strengths too faint for our primitive receivers. It might use channels entirely outside our imagination, neutrinos instead of photons, gravitational ripples instead of radio. The absence of familiar signals does not prove absence of intent. There is also the possibility of dormancy. A vessel may carry transmitters designed to awaken only under specific triggers, a gravitational field, a certain radiation threshold, the detection of technology nearby. If so, Atlas may have remained asleep, passing by in silence, waiting for conditions not yet fulfilled. Its silence could be a form of patience, a message deferred across millennia. More unsettling is the thought that silence itself was the message. To glide across our solar system, conspicuous enough to be seen but refusing to speak, is its own form of communication. It is a riddle without an answer, a test without instructions. It invites interpretation, speculation, and unease. Perhaps that was always the point, not to deliver data, but to deliver uncertainty, to see how we would respond. SETI's negative results, then, may not close the door. They may only remind us of its narrowness. We listen with human ears, expecting alien minds to think as we do, to shout across the stars in radio waves. But intelligence may not be so obvious. Its transmissions may be woven into subtler channels, hidden in mathematics, gravity, or light curves we dismiss as noise. And so, Atlas remained silent. But in its silence, it forced us to confront a deeper question. Are we truly listening, or only listening in ways we already understand? The chemical portrait of 3i Atlas was expected to bring clarity. Spectroscopy, after all, is astronomy's great interpreter, a technique capable of extracting secrets from light alone. By dispersing its glow into spectral lines, astronomers hope to read its composition, what ices, what dust, what molecules it carried across the void. They expected, perhaps, the familiar signatures of water, carbon compounds, or silicates, the fingerprints of comets born in distant planetary nurseries. What they found instead was a mixture both ordinary and disquieting. Some elements did align with expectation. There were hints of water, ice, traces of carbon-based molecules, fragments of the chemistry that seeds comets throughout the galaxy. But woven into this picture were absences, silences where signals should have been. Ratios of elements were skewed, proportions fell outside the ranges seen in solar system comets. Spectral features appeared faint or incomplete, like words cut from a sentence. Was this simply the effect of distance and faintness? Perhaps. Atlas was never close enough for instruments to resolve its secrets cleanly. Noise corrupted the data, uncertainties multiplied. But even within these limits, the inconsistencies troubled researchers. The chemistry seemed both too familiar and not familiar enough, like a voice imitating an accent it did not fully master. If Atlas were natural, then perhaps it came from a system with slightly different elemental abundances, where planetary formation favored unusual compositions. But if it were engineered, then the chemistry might be camouflage, a skin of cometary matter designed to mimic the ordinary, to pass as natural in the eyes of primitive astronomers. Coating a vessel in ice and dust would serve as perfect disguise, shielding it from radiation and suspicion alike. More provocative still was the question of resilience. Some compounds inferred from the spectra should not have endured intact across millions of years in interstellar space. Cosmic rays and ultraviolet light break molecules, leaving rubble behind. Yet Atlas carried them, whole and unspoiled. Could this survival be natural, or did it hint at some unknown preservation, a chemistry tuned not to decay but to endure? Scientists argued over interpretations, caution tugging against curiosity. In official reports, the anomalies were footnotes, uncertainties to be studied further. But beneath the surface, the whispers continued. If 3I Atlas was engineered, then its chemistry was not its essence, but its costume. And if so, then the truth of Atlas may not lie in what it revealed, but in what it concealed. If 3I Atlas was engineered, it must have been built somewhere, and to imagine its origin is to step into the enormity of galactic possibility. For such an artifact to exist, there must be places in the universe where intelligence and technology have not only flourished, but endured long enough to dream beyond the confines of a single star. Where would such a cosmic shipyard be? One vision places it near dying stars. In the turbulent aftermath of stellar collapse, civilizations might harvest the energy of giants in their final throes, using supernova remnants as furnaces to forge matter on scales unimaginable to us. A culture able to manipulate those forces could weave vessels from elements rare in ordinary systems, crafting hulls resilient to cosmic radiation and the claws of entropy itself. Another possibility lies in the cradle of young stars. There, in protoplanetary disks thick with gas and dust, builders might hide their work beneath the cover of natural chaos. A shipyard disguised as a comet nursery could scatter its creations without notice, launching artifacts dressed as debris into the galaxy. To us, they would appear as natural wanderers. To their makers, they would be emissaries. More speculative still are the hidden architectures of the galaxy. Dyson, like spheres cloaking stars, ringworlds orbiting pulsars, structures vast enough to remain unseen because we cannot yet imagine how to look. In such places, perhaps 3 Atlas was not a singular craft, but one of countless vessels, mass-produced in numbers beyond comprehension, seeded into interstellar currents like spores from a great tree. Its fragmentation could even be part of this method, not accident, but replication. A probe designed to break apart in new systems, leaving behind modules to drift onward, each carrying fragments of the whole. If so, our solar system was not its destination, but simply another staging ground in an endless chain of dispersal. And then comes the most haunting possibility, that the builders are gone. The shipyard may be silent, its architects long extinct, their works drifting as fossils of intention. Atlas would then be not a messenger, but a relic, proof that intelligence once crossed the stars, even if it speaks no longer. A fragment of memory cast adrift, waiting to be found by whoever comes after. Whether built in the fires of stars, the veils of disks, or the ruins of civilizations, the thought lingers. Somewhere in the galaxy, there may exist places where engineering and astronomy are not separate pursuits, but one and the same. Places where ships are built not to cross oceans, but to cross eternity. For centuries, astronomy has balanced itself on a fragile line between wonder and restraint. The stars beckon with mystery, but the discipline of science demands caution. Claims must be supported, hypotheses must be tested, extraordinary suggestions must bend beneath extraordinary evidence. When Oumuamua first crossed the solar system, Avi Loeb's bold speculation that it might be artificial sent tremors through the community. Some admired his daring, others recoiled, fearing that such claims risked turning astronomy into spectacle. With 3I Atlas, the fear resurfaced, heavier, darker, more insistent. The fear was not only of ridicule, it was the fear of fracture, of the credibility of the field itself shattering beneath the weight of suggestion. To declare an object engineered is to cross from physics into philosophy, from science into story, and once crossed, the return is perilous. Careers are built on prudence. Reputations can be undone by one reckless word. Many astronomers remembered how, centuries ago, comets were seen as omens, portents of divine wrath. To allow the same kind of mythology to creep back into modern astronomy felt like regression. Yet silence came with its own unease. Data accumulated that could not be neatly explained. Brightness rhythms, improbable stability, suspicious fragmentation. Each anomaly, in isolation, was survivable. Together, they began to whisper of design. And whispers are dangerous, for they spread beyond observatories, out into the public sphere where imagination outruns discipline. Already, journalists asked pointed questions. Already, speculations spread across forums, turning Atlas into a cipher for alien intent. Inside conferences and private correspondence, fear deepened. Not fear of aliens, but fear of losing control of the narrative. What if the public seized upon the artificial hypothesis before science could offer certainty? What if trust in astronomy crumbled, drowned beneath the flood of sensationalism? The silence of radio telescopes, the ambiguity of light curves, these became shields, desperately raised against the rising tide of wonder. But beneath the fear was another shadow, awe. If Atlas truly was engineered, it would rewrite everything. Humanity would not be alone in the dark. We would be part of a galactic story far older and larger than ourselves. That possibility was too vast, too disruptive. To admit it would be to surrender the comfort of isolation, to recognize that the universe does not merely contain us, it may contain others watching us. Thus, fear filled the halls of science. Fear of ridicule, fear of wonder, fear of truth. And in that fear, the debate around 3I Atlas became not just about data, but about the courage to ask a question that could shatter the foundations of what it means to be human. Once the unsettling idea of artificial origins surfaced, however cautiously, it demanded one response above all: testing. Science is not content with speculation. Hypotheses must be prodded, measured, pursued, until they either collapse under evidence or emerge, scarred but intact, into acceptance. If 380LAS might be engineered, how could such a claim ever be examined? The first proposals focused on telescopes. Future surveys, like the Vera C. Rubin Observatory, with its immense wide-field eye, were expected to detect many more interstellar objects. If Atlas was not unique, if other bodies with similar anomalies followed, then patterns could be compared, statistics gathered, and suspicions hardened or dissolved. Perhaps Atlas was only the beginning, a herald of a population waiting to be catalogued. Other ideas turned toward direct pursuit. Some argued for a rapid response mission, spacecraft designed to launch on short notice and intercept the next interstellar object as it entered the solar system. NASA and ESA had already studied concepts like this after Oumuamua. A probe, small but swift, might one day fly alongside a visitor, taking close images, sampling dust, peering into its secrets with instruments far sharper than Earth-bound eyes. If Atlas had been engineered, such a probe might have unmasked it. But dreams of interception collided with reality. Technology was not yet ready to chase objects moving at such staggering speeds. By the time Atlas was detected, it was already too late. No rocket could reach it in time. The object slipped away into the dark, leaving only its echoes in data, and with it the frustration of opportunities lost. Theorists pressed another path: simulations. If Atlas's brightness variations or fragmentation could be modeled more convincingly by artificial mechanisms than natural ones, then circumstantial evidence would grow stronger. Others proposed scouring the sky for fragments that might have been left behind, tiny relics that could have lingered in the solar system, though none were found. Ultimately, the most pragmatic conclusion emerged. Testing the artificial hypothesis would not come from Atlas itself, but from the future. Each new interstellar visitor would be a chance to refine the search, to build the tools capable of intercepting them, to design missions waiting like coiled springs for the next messenger from the dark. Yet even this restraint carried a quiet acknowledgement. By designing missions to pursue such objects, humanity was admitting the possibility that one of them might not be natural. The act of preparing to test the hypothesis was itself a concession that it could be true. And so, the testing of 3I Atlas was not a conclusion, but a vow. The next time a body from the void arrives, we will be ready to ask the question fully, without fear, with instruments sharp enough to pierce the mask of mystery. Among the strangest suggestions surrounding 3I Atlas was the idea that its behavior might be connected, however faintly, to the great riddle of modern cosmology: dark energy. This invisible force, inferred from the accelerated expansion of the universe, remains one of the deepest mysteries in physics. It acts everywhere, subtle yet overwhelming, shaping the fate of galaxies while eluding direct detection. To invoke it in connection with Atlas was audacious, but the parallels invited curiosity. Some theorists noted that Oumuamua's unexplained acceleration, faint but undeniable, echoed the cosmic repulsion attributed to dark energy. While mainstream explanations leaned toward outgassing or radiation pressure, the coincidence stirred speculation. Could interstellar artifacts be testing or harnessing this universal field, tapping into the same energy that drives the universe apart? Atlas, with its coherence and puzzling light curve, seemed to extend this unease. Its motion was steady, precise, almost resistant to the perturbations expected from sunlight or outgassing. In whispers, some wondered, could its path have been tuned not by chemical thrust or gravity, but by interaction with the fabric of space-time itself? If so, dark energy, this mysterious background of the cosmos, might serve not only as a cosmological constant, but as a tool. The concept is staggering. For humanity, dark energy is an enigma glimpsed only through distant supernovae and the redshift of galaxies. For an older intelligence, it might be an engine. If Atlas was engineered, perhaps it was a device designed to probe this field, to measure its fluctuations, to map its strength across interstellar voids. In this interpretation, Atlas was less a messenger than a scientific instrument, a wandering lab carrying out experiments on the very substance of cosmic acceleration. Others ventured further. What if Atlas was not only testing dark energy, but powered by it? A vessel exploiting the energy embedded in space-time could travel indefinitely. Its endurance explained not by improbable resilience, but by physics we have only begun to imagine. Its glow, its fragments, even its rhythm of brightness, might be signatures of a technology tuned to forces we barely understand. Mainstream science rejected such leaps, preferring more mundane models. Yet the allure persisted. Linking Atlas to dark energy transformed it from anomaly into possibility, a bridge between our deepest mysteries and the potential of alien engineering. If true, then Atlas was not only a visitor from another star system, it was a key, drifting silently past Earth, hinting that the greatest force in the universe may already be harnessed by others. When considering the unsettling possibility that 3I Atlas might be engineered, the voice of Stephen Hawking often returned like an echo from the recent past. In his final years, Hawking warned repeatedly of the dangers of contact. He imagined a scenario not unlike the history of Earth itself, where a technologically superior civilization meets a less advanced one, and the result is conquest, not dialogue. To him, a signal from the stars was not cause for celebration, but for caution. In the shadow of Atlas, his warnings took on a new weight. If the object were truly a probe, then its silence might not be reassuring. It might be intentional. Perhaps it was not designed to speak to us, but to watch, to measure, to test. In Hawking's terms, that silence could be the most ominous sign of all evidence of a civilization that observes before it chooses whether to reveal itself. There was another aspect of Hawking's thought that haunted discussions of Atlas. He had often spoken about the fragility of our species, the razor-thin margin of survival on a small, vulnerable planet. For him, the only long-term hope for humanity lay in spreading to the stars. But the gulf between hope and capability is vast. If Atlas was proof that others had already bridged that gulf, then the contrast was stark. We were still fledglings dreaming of Mars, while others might already be scattering artifacts across the galaxy. Hawking also speculated about the unknown forces of physics, black holes, cosmic strings, quantum instabilities that might one day be harnessed. The very thought of engineered interstellar objects suggested that somewhere, intelligence had mastered tools we cannot yet grasp. In that mastery lay both awe and fear. Awe at the ingenuity required, fear at the power it implied. In this sense, Atlas became not only a scientific anomaly, but a philosophical mirror. It forced humanity to consider whether we are ready to know that we are not alone, whether we are mature enough to face the possibility of intelligence far older, far more capable than ourselves. Hawking's shadow loomed over every whisper of engineering. His caution urged restraint, to observe, to learn, but not to assume that contact would be safe. If Atlas was indeed a messenger, its silence may have been a kindness, or it may have been a warning, an unspoken reminder that the universe is older, stranger, and perhaps more dangerous than we dare to believe. The contemplation of 3I Atlas as an engineered object inevitably turned inward. For all the speculation about alien builders and distant shipyards, the most haunting aspect of the mystery was what it revealed about us. To look at Atlas was to gaze into a mirror, a reflection not of the object itself, but of humanity's own dreams, fears, and ambitions. When we asked whether it might be engineered, we were really asking, could we one day do the same? Could our species construct vessels capable of surviving the dark between stars, of enduring for eons, of bearing messages across cosmic gulfs? If Atlas was real and artificial, then the universe had already answered yes, and in that answer lay both inspiration and dread. For centuries, humanity has launched its own fragile emissaries: Voyager, Pioneer, New Horizons. These machines, small and golden, carry our songs, our maps, our greetings, cast like bottled notes into the interstellar sea. They are crude by comparison, vulnerable to radiation, doomed eventually to silence, but their very existence proves that the urge to reach beyond is not alien, it is deeply human. To imagine Atlas as engineered is to imagine our own destiny, stretched into scales of time and space we can barely conceive. Yet the mirror cuts both ways. If Atlas was built, it may not have been built for benevolence. Its purpose could be indifferent or even hostile. Perhaps it is a probe to measure habitable systems, or a fragment of expansion that cares nothing for those it passes. In projecting intent onto it, we reveal our own anxieties, that exploration and domination may be inseparable, that curiosity is never free of risk. The mirror also reflects our philosophy. To wonder whether Atlas was engineered is to reveal how desperately we yearn not to be alone. Even in the absence of proof, we bend data toward meaning. We shape anomalies into stories of contact. The mystery awakens an ancient hunger, the need for companionship in the cosmos, the hope that intelligence is not unique to Earth. Thus, Atlas was not only an object in the sky, but a question in our minds. What does it mean to be human if others are out there? Are we the beginning of intelligence, or only one note in a greater symphony? The mirror of Atlas does not answer it, only forces us to confront our own reflection, to see ourselves as both fragile and striving, frightened and ambitious, bound by the same mystery we project into the stars. When the mystery of Three-Eye Atlas pressed too hard against the walls of conventional explanation, some scientists and philosophers turned not outward, but sideways toward the possibility that the very universe we inhabit is not singular. The multiverse, long debated in physics, offers a framework in which countless universes coexist, each with its own laws, constants, and origins. To connect Atlas to such a concept was audacious, yet the temptation grew irresistible. If Atlas were engineered, could it have come not merely from another star system, but from another universe? Some cosmological models, born from inflation theory, propose that our cosmos is but one bubble among many. If so, the borders between universes might not be entirely closed. Quantum fluctuations, wormholes, or phenomena we cannot yet describe might allow matter or artifacts to drift across. Could Atlas be such a trespasser, an interloper not only between stars but between realities? The multiverse temptation grew from Atlas's peculiarities. Its coherence, its odd chemistry, its timing, all could be seen as evidence that it did not belong here at all. If its builders existed in another universe, their technology might reflect physics unlike our own. What seems anomalous in our frame of reference could be natural in theirs. Its glow, its stability, its fragmentation, perhaps they obey rules foreign to our cosmos, rules that slipped into ours only through this object. Philosophers found in this idea a kind of poetry. The multiverse had often seemed a sterile mathematical construct, beautiful but unreachable. Yet Atlas, drifting across our solar system, offered the faintest suggestion of contact, not just with another intelligence, but with another reality itself. It was a reminder that mystery expands not only across distance, but across dimensions. Skeptics, of course, recoiled. The multiverse is difficult enough to argue even in the abstract. To attach it to a single interstellar object seemed reckless. Without evidence, it risked collapsing into metaphysics. Yet the speculation persisted because it touched a deeper hunger, the longing to believe that we are not only part of one universe, but participants in something larger, a grand architecture of countless realities. In this view, Atlas was not only engineered, It was a shard of a higher order, a fragment from beyond our horizon, a sign that universes themselves may not be as separate as we imagine. The multiverse temptation did not solve the riddle of Atlas, but it expanded it, reminding us that the mystery of one object could ripple outward until it touched the very foundations of existence. Among the more unsettling whispers surrounding 3I Atlas was the possibility that it was not a messenger, not a relic, not even a probe of exploration, but a test, a device engineered to examine the most fragile feature of our cosmos, the vacuum itself. In quantum field theory, the vacuum is not empty. It seethes with fluctuations, particles flickering into and out of existence, energies that cannot be stilled. Our universe may rest in what physicists call a false vacuum, a metastable state that appears solid but could, under the right trigger, collapse into a lower, truer energy state. If such collapse ever occurred, it would expand outward at the speed of light, rewriting the laws of physics, extinguishing every atom, every star, every thought. Some theorists, cautious, almost reluctant, have speculated that advanced civilizations might probe this instability. To test the strength of reality itself, one could send devices to measure the vacuum at vast distances, far from home. If catastrophe were triggered, it would unfold elsewhere, sparing the origin world. It is a chilling thought. Probes as sacrificial instruments, cast into other star systems to tap at the walls of existence. Atlas, with its coherence and uncanny behavior, fit too neatly into this nightmare. Was its glow a byproduct of exotic fields, its stability a necessity for experiments conducted on space-time itself? Was its fragmentation not failure but procedure, modules separating to measure vacuum fluctuations in multiple configurations? To most astronomers, this was unthinkable. There is no evidence that Atlas destabilized anything, no scar left in space-time by its passing. Yet the mere possibility that an object could be engineered to test such forces was enough to seed dread, for it suggested that intelligence in the cosmos may not always seek contact or beauty. It may seek knowledge at any cost, even if that cost is the annihilation of worlds not its own. Stephen Hawking himself once warned of vacuum decay, a spectre born from the equations of particle physics. To link Atlas with such a doom was speculative, even reckless. But in the dark corridors of thought, some admitted the possibility. What if Atlas was not a gift, but a blade? What if it was a quiet reminder that the universe we inhabit may not be stable, and that others older, colder, may already be probing its breaking point? In this vision, Atlas becomes more than anomaly. It becomes omen, a silent envoy not of companionship, but of peril, a whisper that the universe itself may one day be undone, not by fate, but by curiosity unbound. In the wake of Oumuamua, Borisov, and Atlas, humanity began to look not only at the stars but at itself, asking, what tools must we build to meet the next visitor properly? For if 3I Atlas had been engineered, if its secrets had slipped through our fingers, then the loss was not cosmic, it was our own failure to be ready. The first great hope lay in the Vera C. Rubin Observatory in Chile. With its immense 8.4-meter mirror and sweeping sky survey capability, Rubin promised to catalogue the heavens with unprecedented depth and frequency. Night after night, it would scan the sky, catching the faint signatures of interstellar wanderers long before they skimmed past unnoticed. Where Oumuamua and Atlas had been detected late, Rubin would see their kin early, granting months or even years of warning. Alongside Rubin, the James Webb Space Telescope opened its golden eye. Though designed primarily for galaxies and exoplanets, Webb's sensitivity to faint infrared signals made it a powerful ally in probing the chemistry of small, cold objects. If another Atlas arrived, Webb could dissect its glow in detail, distinguishing natural ices from exotic alloys, chance fragments from deliberate construction. Future concepts pushed even further. Mission proposals envisioned spacecraft on standby, coiled like arrows, waiting for the next target. Rapid launch interceptors could be readied to chase down interstellar objects, attaching themselves as companions, photographing their surfaces, sniffing their dust. Some envisioned swarms of microprobes, inexpensive and numerous, cast outward in all directions, ready to rendezvous with the next anomaly before it vanished into darkness. Particle accelerators on Earth, too, played a quieter role. By colliding protons at immense energies, scientists sought to uncover the hidden physics that might explain exotic structures, materials capable of surviving interstellar journeys, engines that might harness radiation pressure, fields that might stabilize rotation. To understand Atlas, humanity had to probe the fabric of reality itself, building machines that could one day make us engineers of similar endurance. These tools were not yet enough. Even Rubin, even Webb, even the dreams of interceptors could only scratch the surface. But they represented a beginning. They were the acknowledgement that we live in a galaxy alive with motion, and that our duty as watchers is to be ready not merely to observe, but to confront the unknown with instruments sharp enough to pierce mystery. In building them, we revealed something essential, that Atlas had not only passed through our solar system, but through our imagination. It forced us to look at our technology not as it is, but as it must become. To meet the cosmos, we must grow. To seize the next messenger, we must be willing to reach as far as it has traveled. While telescopes searched the heavens for new visitors like 3I Atlas, another front of inquiry unfolded deep beneath the Earth. Particle colliders, those vast rings where protons are smashed together at near-light speeds, were probing the invisible framework of reality itself. If Atlas was engineered, then its builders may have harnessed physics beyond our grasp, forces and materials born from realms we only glimpse in particle collisions. The Large Hadron Collider at CERN had already revealed the Higgs boson, confirming the field that gives particles their mass. But beyond that, triumph lay greater mysteries. Dark matter, dark energy, hidden dimensions, exotic particles that might lurk just beyond our detection. Some theorists speculated that Atlas's coherence, its resilience against radiation and fragmentation, might hint at materials stabilized by principles drawn from such hidden physics. Perhaps it was not merely ice and rock disguised, but matter woven with precision into structures that could endure the gulfs between stars. Engineered matter may not resemble anything we know. It could be lattices of stable quark-gluon plasma, sheets of exotic carbon architectures, or alloys whose bonds are tuned by quantum fields. In colliders, we see only fleeting sparks of such states, vanishing in trillionths of a second. But what if others have learned to capture them, to freeze them into permanence? If so, Atlas may have been less a comet than a vessel clad in the very substance of alien physics. The possibility was daunting. Humanity's colliders are crude compared to the scale required to master such matter, but each experiment is a step, each detection a hint. As we push energy boundaries, we edge closer to glimpsing the toolkit from which an object like Atlas might have been forged. Even its silence could be explained by such physics. If its transmitters operated in particles we do not yet harness, neutrinos, axions, gravitons, then our receivers would be deaf. To us, it would appear mute. To its builders, it may have been eloquent. Thus, Atlas forced us to consider that alien engineering may not lie within the chemistry of the familiar, but within domains we barely touch. To understand such a thing, we must build machines not only to look outward, but inward, peeling apart the smallest scales of matter until we, too, learn how to shape reality. And perhaps That is the deeper lesson, that the mystery of Atlas is inseparable from the mystery of physics itself. If it was engineered, then the path to understanding lies not in superstition, but in the colliders beneath our feet, where sparks of alien possibility flicker into being for a heartbeat and then vanish. When 3I Atlas finally slipped away, vanishing into the dark beyond the reach of telescopes, it left behind not answers but a silence that grew heavier with time. We had seen it, measured it, speculated upon it, and then it was gone. In its wake, astronomers turned their eyes back to the sky, waiting for the next arrival. More interstellar objects would surely come. The galaxy is full of debris, fragments ejected by the birth and death of stars. Yet in the years since, the silence has lingered, each night of emptiness deepening the unease. This silence is not merely the absence of new objects, it is the silence of meaning. If Atlas was engineered, then its passing without further signal, without confirmation, was itself a kind of message, one that refuses to clarify, one that withholds. It is as though we were shown a riddle only once, fleetingly, and then the riddle teller vanished into the shadows. The quiet reminds us of Oumuamua. That visitor, too, offered anomalies that stirred whispers of design, only to depart without a trace. Borisov, the second interstellar guest, appeared natural, almost reassuring, yet it too was brief, a reminder that our glimpses are always temporary. Atlas, following them, seemed to complete a trilogy, and then silence fell, as though the curtain had closed. Some scientists see this silence as natural, even comforting. Our surveys are still young, our instruments still limited. Visitors pass unseen every year. Patience, they argue, will bring abundance. But others hear something deeper in the quiet, something deliberate. If these were probes, then perhaps their arrivals were not random. Perhaps they come rarely, by design, spaced apart by centuries or millennia, timed to civilization's awakenings. If so, then the gap itself is part of the communication. Philosophically, silence is as powerful as speech. In music, the pause between notes is what gives the melody shape. In human dialogue, what is not said often carries more weight than words. So too with Atlas. Its silence expands across time, forcing us to live with the questions it raised. This is the silence that unnerves most of all, not the silence of absence, but the silence of intention. A silence that grows louder the longer it persists, until it becomes indistinguishable from a voice that says nothing and yet means everything. By the time 3I Atlas had vanished into the dark, the scientific record contained only fragments, brightness curves, spectroscopic hints, orbital calculations, scattered photographs. None of it conclusive, none of it sufficient. The object remained forever beyond reach, leaving behind only ambiguity. And in that ambiguity lay a deeper truth, that sometimes the most enduring legacy of discovery is not certainty, but uncertainty itself. Science thrives on answers, yet the cosmos often denies them. Oumuamua left us with unresolved acceleration. Borisov left us reassured but puzzled by its unusual chemistry. Atlas carried echoes of both: coherence, silence, suggestive fragments that would not settle neatly into any category. The result was not a revelation, but a philosophy, a recognition that our hunger for meaning exceeds our ability to extract it. This uncertainty is not a failure, it is a mirror of the universe itself. Cosmology is built upon mysteries that defy closure: dark matter, dark energy, the origins of time, the possibility of multiverses. Atlas joined that lineage, an object that resists finality, teaching us that to live with questions is as important as to answer them. Philosophers of science have long warned against the illusion of closure. Every answer opens further questions. Every explanation deepens the horizon of mystery. Atlas, whether natural or engineered, embodies this principle. If natural, it reminds us that nature is more complex than our models allow. If engineered, it reminds us that we are not alone, and that others may play with rules we have barely learned. In both cases, uncertainty remains. But there is power in that uncertainty. It awakens humility, reminding us of the limits of knowledge. It stirs imagination, urging us to dream of possibilities beyond the comfortable. And it deepens wonder, teaching us that mystery is not an obstacle to truth, but a companion to it. Perhaps then, the greatest meaning of Atlas is not what it was, but what it refused to reveal. Its silence, its strangeness, its fleeting passage, all these force us to confront the fragility of knowing. To live with Atlas is to live with a riddle unanswered, to dwell in the space where science and philosophy blur, where certainty dissolves into awe. In that space, we are reminded that the universe is not obliged to explain itself to us. We are small, fragile observers, permitted only glimpses, and perhaps it is in those glimpses, not in closure, but in uncertainty, that the truest beauty of discovery lies. When the story of 3I Atlas is told, it is not the data tables or orbital diagrams that linger, it is the silence, the shimmer, the fragile possibility that for a fleeting moment we brushed against something more than nature. Its passage was brief, its evidence inconclusive, its mysteries unresolved. Yet it left behind a resonance that echoes still, a reminder that the cosmos is not merely a backdrop of stars, but a stage where questions take form and vanish before answers can arrive. If Atlas was natural, it revealed the subtlety of chance. It showed us that the universe can craft bodies that mimic intention, that physics alone can generate forms so precise, so improbable, that they force us to wonder. In that sense, it becomes a lesson in humility. Nature is stranger, more inventive than we are often willing to admit. If Atlas was engineered, then its implications are vast beyond words. It would mean that somewhere in the galaxy, intelligence has already walked far ahead of us, building artifacts that endure across millions of years, dispatching emissaries to drift between stars. Such a realization would change everything, not only science, but philosophy, history, identity. It would mean we are not alone and never have been. But perhaps the truth is not meant for us yet. Perhaps Atlas was only the opening chapter of a longer story, one in which future visitors will arrive, one in which our instruments and our courage will be ready to meet them. Or perhaps its meaning lies precisely in its ambiguity, a reminder that mystery itself is the gift, that the universe is not a book we close with answers, but a poem we live within, forever unfinished. In the end, Atlas leaves us with reflection rather than resolution. It reminds us that science is not merely about collecting facts, but about confronting the unknown with wonder intact. It reminds us that philosophy is not abstract, but lived etched into the very sky above us. And it reminds us that to gaze into the night is to gaze into ourselves, to see both our limits and our longing mirrored back in the silence of the stars. Whether natural or engineered, 3 Atlas has already fulfilled its role. It has forced us to question, to imagine, to dream. It has reminded us that to exist at all is to dwell in mystery. And perhaps that is the truest message of all, that the cosmos speaks not in certainty, but in questions that echo across eternity, waiting for us to learn how to listen. And now, as the echoes of 3I Atlas fade, let the mind drift with it into the quiet beyond. Imagine its fragments, still gliding silently through the darkness, each shard a lantern carried by invisible tides. They are no longer questions to solve, but stars of their own, fading slowly into the distance. Breathe with the rhythm of that silence, slow, steady, like the turning of the earth beneath the stars. Feel how vast the night is, and how small our place within it, and yet how wondrous that we are here at all, able to see, able to wonder. The story of Atlas has no final answer, only reflection. But that is enough. Let it remind you that not all mysteries demand resolution. Some are meant to remain open, shimmering at the edges of thought, lulling us into awe. Like the hush before dawn or the pause between waves, mystery has its own kind of peace. So let the tension ease. Let the questions soften. The object has passed. The sky is quiet again. And what lingers is not fear but calm, a reminder of the beauty of uncertainty, of the quiet companionship of stars. Close your eyes and imagine the slow drift of interstellar space, the gentle dust, the faint light, the silence vast and endless. In that silence, you are safe. In that silence, you are at rest. Sweet dreams,